Hello, my name is Shannon Aurelia. I'm from Indonesia. This video is about the Cortex demo. This is a bit about the site, and this is the first page, as you can see. I'll explain a bit more. This part here is the architecture of the Cortex, and this is the open source. If you'd like to see, if you would click here, you can actually access the open source code. So yeah, so most of our thoughts, most of the valuable thoughts that we have, can disappear within seconds. So when we would think about it, it can, disappear. An idea then appears, usually while we're studying, working, or solving a certain problem. But before we can actually develop these kinds of thoughts, it's replaced by something that, even when we write it down, it is often this isolated note that we never really find again. It's usually a thought that we don't necessarily think that is quite important, but it's important that we actually develop the thoughts that we have in our minds so that we could, develop other things that may be important to us. So I built Cortex with this idea in mind to sort of capture the thoughts and preserve the connections that form from these thoughts that would make them valuable necessarily. So the cortex here is essentially an interactive algorithmic laboratory that really transforms a certain fragmented way of thinking into this sort of evolving, searchable digital mind. It's basically translating all the stuff that you have in your mind in somewhere that is digital. It's like a digital database, but it's not just saving data. So it doesn't really simulate the biology of the brain. It more so models the structure of how we think or the thoughts through our memories, concepts, relationships, or any other reasoning paths that users can usually inspect. Now, maybe I'll discuss something about this. So, what if algorithms could preserve the connections between ideas before they disappear? So, if I were to capture it, right, the thought moves through sort of six visible stages, and it's a bit difficult when I was first trying to formulate what exactly defines the thoughts that we have in our brain. So I did a little bit of research, and these were the things that I sort of captured. So first is this section here, capture. I'm not sure if you can see my cursor, but if you see here in the live cognitive pipeline section, there's the capture section, there is the interpret section. So there's capture, interpret, remember, connect, reason, and visualize. Now, the system extracts its main concepts and identifies it as a question, which creates a new memory node. And this compares the nodes with the thoughts that were already inside the cortex. So it's basically making new connections, just sort of like how the brain works, essentially. This is just a simplified concept of it. Now, a new thought can appear at the top of the memory archive. So the inspector then shows its extracted concepts and signal strength, and then beneath it, the cortex would sort of rank related memories to each other and explained that the connections are based on a semantic meaning, as in based on what the words are, when they're next to each other and so on. And then they share a conceptual context. So it's sort of like it's a bit of how the brain sort of works. So I can sort of select any memory to make it to make the active thought and immediately inspect a different set of relationships. I can also search the archive by a phrase or a concept. The system telemetry updates as the mind grows, and it would show the number of memories, the memory nodes, and the graph connections, as well as the active concepts. So say I would click here. What are you thinking? Let's say type an idea, question, observation, or an unfinished thought. Let's say, uh, why is a circle, or actually, let's not do that. Um, does a circle have corners? Say, capture a thought. No, it's thinking. So these are sort of the processes of what it's going through, as you can see here. Now, The visual brain is not really a static image. It's usually a network that activates as information moves through a certain pipeline. Here, this live cognitive pipeline is what I'm talking about. Now, while the surrounding orbital layers can represent the memory, so this is essentially what I mean by the memory nodes. This is what it's sort of orbiting by as they represent the memories as well as the reasoning modules. Now, the architecture of this cortex, I kind of detailed it in the GitHub as well. It's accessible in here, docs. In this architecture markdown file, I kind of laid it out here, but essentially the architecture view kind of explains the complete pipeline of all of this. Sorry. The connection between two thoughts is usually represented as a weighted combination of semantic similarity or shared concepts and temporal context. So the formula that I used was this one. Yeah, this is the connection model that I used for this architecture. Now, the hackathon prototype uses a sort of lightweight implementation of this. So it kind of runs instantly without an account or an API key. In this case, I did not implement any API keys or anything of that sort. The system is basically mo it runs based on modules, so it's pretty modular. So it can later use more embedded stuff later on, or language models and graphite database, but it doesn't really redesign the entire product. So this is sort of like regardless of all those other things. Now, I built the Cortex with Next.js, React, TypeScript, and CSS, and SVG for images. It's also detailed inside here. You can see it in the GitHub repository. Yeah, it's right here. TypeScript, JavaScript. I also used CSS. I'm not sure why it doesn't show up there, but yeah. The greatest challenge when it comes to making this was sort of representing the thoughts as something conceptual. So it wasn't easy trying to quantify what these pillars are, these pipelines. Um, so usually a thought is more than just a text, you know. A thought is it has relationships between certain words, it has context, it has unfinished reasoning. It's very hard to conceptualize or essentially define what a thought is. So I also wanted to experience this feel of living in like a cosmic laboratory. So this is why the theme is more cosmic and sort of lab-like without letting the visual design become sort of meaningless. I'm trying to incorporate the design is not really that um it's pretty basic. It's not really extravagant, I guess, but every major interface element here, it's kind of the same thing repeatedly. My challenge was mostly part from how to conceptualize the idea. It wasn't necessarily how to design the website, so it's more so on how I want to get my idea across. So say if I have the thought, does a circle have corners, for example, how would I, define these, capture, interpret, remember, connect, reason, visualize, and so on. That was really difficult, but these are the pillars that I ended up coming up with. Um, I guess that's it. The next step, I guess, is being persistent in encrypting these kinds of memories or finding another way of defining this semantically, I guess, in a vector search, maybe. Or maybe capturing voices from users, or maybe having a user-controlled reasoning model. There are many other models besides the one that I'm using, obviously. I was just trying to keep this very simple, trying to keep this as a light, fun, beginner-friendly project. So, I guess this is a very simple, brief introduction video to the Cortex. And yeah, I guess that's pretty much it. Thank you for uh thank you for watching this video. I hope it's not too long. If you would like to see all the other sites, you can check out this Versal website. Maybe let me erase the tag. Yeah, this is the site that you can visit. It's also available on the GitHub site. It's also available on the project site inside of uh, the submission. Thank you.